Good day, everyone. And today is the first day when you're going to answer your module. So, the first topic for grade 8 mathematics is about factoring polynomials. So, this time, I'm going to discuss to you how to factor polynomials using greatest common monomial factor. But, let us recall first what is factor. What do you mean by factor? Okay, when you say factor, that is a number or algebra expression that divides another number or expressions evenly. That is with no remainder. Okay, say for example, 20. Okay, so we're going to search for a number or numbers that divides the another number or expressions or this 20 evenly with no remainder. Okay, so what are those? So, let's list all the factors of 20. Okay, of course, 1. Why 1? Because when you're going to divide 20 by 1, that is 20. So, there is no remainder. How about 2? Okay, 2. So, when you divide 20 by 2, that is 10. So, still, 2 is a factor of 20. Okay, next, 4. Why? Since 20 divided by 4, that is 5. That is also a whole number, no remainder. Next, 5. Okay, when you divide 20 by 5, that is 4. And next, 10. So, 20 divided by 10, that is 2. So, there is no remainder again. And last one is 20. So, the 20 divided by 20, that is 1. So, the factors of 20 are 1, 2, 4, 5, 10, and 20. Let's have another example. How about 10? Let's find the factors of 10. Okay. So again, factors is a number or algebra expression that divides another number or expressions evenly. There's with no remainder. Of course, 1. So, okay, 1 is a factor to any expression or to any number, actually, class. Okay, 2, yes, 2. 10 divided by 2, that is 5. 5. 10 divided by 5, that is 2. There's no remainder. And lastly, 10. The factors of 10 are 1, 2, 5, 10. So this method is listing method. You list all the factors. Okay, from these two numbers, 20 and 10, we're going to look at the common factor. That is the greatest common factor. I guess everybody is very what is greatest common factor. Okay, greatest common factor. So look for the number, the common factor is the greatest. So here, 1 is the common factor for 20 and 10. 2, 5, and 1, 2, 5, and 10. That is their common. They are the common factors. But we're going to search for the greatest. So, obviously, the GCF, greatest common factor, is its abbreviation is GCF. The GCF of 20 and 10 is 10. Okay, that's it. 20 and 10 is 10. Okay, again, the GCF of 20 and 10 is 10. Okay, how about if we're going to get the GCF of 4x cubed and 8x squared? So as you notice, there is x cubed and x squared. So we're not dealing here purely numbers. So we're dealing here algebra expressions. So, or variables. So since we're dealing with that algebra expressions, so we're not going to use the word GCF. Instead, we're going to use GCMF. Okay, G, that is greatest. C for common. M for monomial. F, that is factor. So M is just the new word here. So GCMF is the greatest common monomial factor. Okay. A while ago, we used listing method in finding the GCF of 20 and 10. Here, we can do that also. But where it's really time consuming. We're running out of time, or we're going to consume more time. So I'm going to introduce to you a new, or this is not new, this was introduced to you when you were elementary. This method. This is prime factorization. Okay, from the word prime, so we're going to look factors that are prime or prime numbers. So what is this prime number? So to recall, prime numbers are numbers whose factors are only 1 and itself. Okay, example 2. 2 factors of 2 are only 2 and 1. So 2 and itself. 1 and itself. So 1 and 2. 3, the factors of 3 are only 3 and 1. Okay, let's do that. 4x cubed. Okay, 4. Look for their prime factors. That would be 2 times 2. X cubed. That would be x times x times x. So x is multiplied 3 times. So that would result to x cubed. Next, 8x squared. So 8, that is 3 2s. So 2 times 2. Okay, there is times 2. But in prime factorization, the tip class, you need to align those factors that are similar. So since here it's x here, so that's not the same with 2 or different from 2. So you write another 2 here. So times 2. Okay, how about x squared? X squared is just times x. So you write here times x. Okay. And then you look for their common factors. So here 2. Okay, and now I crush it so that it's simple. It's more simple for us to determine or to crush out the used common factor. Okay, another common, another 2 times another common x, another common x. But here it is x has no common with 8x squared. This also 2 has no common with 4x cubed. And then so you multiply common factors, the common prime factors. 2 times 2, that is 4. X times x, that's x squared. Okay, so meaning the GCMF of 4x cubed and 8x squared is 4x squared. Another example in finding the GCMF or the greatest common factor. Okay, let's have here 15y to the power of 6 and sorry, we're not going to write 9z and 9z. Okay, let's have it. So we're going to use the prime factorization method since this thing method is really hard. So let's have here 15y to the power of 6. So 15, that is, so find the prime factors. It's 3 times 5. Both 3 and 5 are prime numbers. 3 times 5. And y to the power of 6, it is y multiplied 6 times. So, y times y times y times y times y times y. Okay, that's it. How about for 9z? Okay, 9z. Okay, for 9, that's obviously the prime factors are 9, 3 multiplied by another 3. So that's 3. Since after 3 for 15y to the power of 6 is 5, so you will put here 3. And then for z, there is no z here since they are y's. So multiply by z. Now, look for their common factor. So it's very clear the common factor is only 3. So meaning the GCMF of 15y to the power of 6 and 9z is 3. Okay, we're done finding the GCF or the GCMF of two terms or two monomials. Now let's have polynomials. So you're going to find their GCMF. So let's have here number 1. 6x plus 3x squared. So as you notice, there are two terms here. This is binomial. So what are you going to do is you look for their, of course, GCMF. So you have your, let's start with the number. 6 and 3, their common, or their GCF, or I mean, yeah, GCF is 3. Okay? For x and x squared, their GCMF is also x. Tips or, yeah, I'll give you tip. So when you're given with variables, the GCF there is the variable with the smallest exponent. So for x and x squared, that's x. Okay? And then you look for the other factor. So 3x is obviously the GCMF or the greatest common monomial factor. But we're going to look also for the other factor. How? So you just divide each term. So you have your 6x. You divide it by the GCMF, which is the 3x, plus 3x squared divided by the GCMX also, that's 3x. Okay, next. Copy 3x. So now you have your 6x divided by 3x. So 6 divided by 3, that is 2. X divided by x, that is 1. Okay? Why 1? Okay. For example, 5 divided by 5. You're not going to say 0. 5 divided by 5 is 1. So if you have x divided by x, that is 1. So 2 times 1, that's obviously 2. Next, 3x squared divided by 3x. 3 divided by 3, that is 1 also. X squared divided by x squared. I mean x. So that is x. Y. What I did here is just subtract the exponent. Okay, recall. I will write here, recall. In rules in, I mean loss and of exponent. So if you have your a to the power of n over or divided by a to the power of n. So what are you going to do here is you just subtract the exponent. So m minus n. Okay? Recall. So here x squared. So 2 for the x. Class, there is no exponent that you see for x, but obviously the exponent for x is 1. Understood na nga 1 ang exponent. So 2 minus 1, that is 1, or that's just x. Why is it I did not put 1 for the numerical coefficient of x? Of course, it's obvious that the numerical coefficient of x is 1. No need to write it. Okay? So again, the factors of 6x plus 3x squared are 3x plus, multiplied by the quantity of 2 plus x. Okay? Class, you can check actually your answers. Okay? I'll give you a tip here. How? So, 3x, you just multiply the given factors or the factors that you have or that you got. Okay, you multiply. So here you distribute 3x times 2, that is of course 6x. 3x times x, that is 3x squared. So what did you notice? So you come up with the product of the given polynomial. Let's have another example in factoring polynomials using GCMF. Okay, so you have here number 2, 12x cubed y to the power of 5 minus 20x to the power of 5 y squared z. Okay? So you copy 12x cubed y to the power of 5 minus 20 x to the power of 5 y squared z. Okay, so you look for the GCMF. So let's start with the numbers. So for 12 and 20, obviously their GCMF is, yes, 4. Okay, 4. Since when you divide 12 by 4, that's 3. 20 divided 4, that's 5. So, that's a whole number. There's no remainder. Okay, for x cubed and x to the power of 5. Okay, x cubed and x to the power of 5. So, I said a while ago that the tip for finding the GCF or GCMF is you select the variable who has the smallest exponent. So, that is x cubed. Okay, x cubed. Now, for y to the power of 5 and y squared. So, that's obviously y squared. Okay, how about z? As you notice, at 12x cubed y to the power of 5, there is no z. So, meaning, that's obvious that z is the not common factor for the two terms. Okay? So, meaning 4x cubed y squared is the GCMF. Now, let's look for the other factor. How? So, just divide each term by the GCMF. 4x cubed y squared. So, you have 12x cubed y to the power of 5 divided by 4x cubed y squared minus 20x to the power of 5 y squared z divided also with the GCMF 4x cubed y squared. Okay? Okay, let's do it. 4x cubed y squared. Okay, 12 divided by 4, that's 3. X cubed divided by x cubed, that's 1. 1 times 3, that's 3 only. Y to the power of 5 divided by y squared. As I've said, just subtract their exponent. 5 minus 2, that is 3. So, 3y cubed minus Okay, minus 20 divided by 4. That is 5. Okay, x to the power of 5 divided by x cubed. So, just subtract their exponent. That would be 5 minus 3, that is squared. Okay, for y squared divided by y squared, that's 1. Multiplied by 5x squared, obviously it's 5x squared. Then, z. Since there is no z in the denominator, so just write it. Okay. So, meaning, the factors for 12x cubed, y to the power of 5 minus 20 x to the power of 5 y squared z are 4x squared, cube y squared multiplied by 3y cube minus 5x squared z. Class, remember, I told you that you can check your answers by multiplying the factors and then you come up with the given polynomial. Okay, another example. So, you have here 28 x cubed z squared minus 14 x squared y cubed plus 36 yz to the power of 4. So, you have here 3 terms. This is trinomial. Okay. So, just let's copy first. 28 x cubed z cubed minus 14 x squared y cubed plus 36 yz to the power of 4. So, the same thing, you're going to find our GCMF. So, let's start with the numbers. 28, 14, 36. So, for this class, when you're going to use the listing method or the prime factorization, you come up with the GCMF of, okay, 36 is 4 times 9. 14 is 7 times 2. 28 is 7 times 4. So, their common is 2. Okay? Okay. Okay, I'll illustrate you. It's if you can visualize it. Okay, let's have here 28, 14, 36. So, 28, prime factorization tayo. 4, that's 4 times 7. So, 4 is, that's not prime. So, it's 2 times 2 times 7. 14 is 2 times 7. 36 is 4 times 9. Yes, 9. 4 is 2 times 2. 9 is 3 times 3. So, very clear. Their common factors. Common factor is just 2. That is why I write a while ago 2. Okay? Okay. So, their GC. For the numbers, their GCF or GCMF is 2. Now, proceed with the variables. So, x cubed, x squared. There is no x for the third term. So, meaning x is not GCF or GCMF. How about for y? For the second term is y cubed, third term y. But there is no y for the first term. So, y is not included in the GCF. How about the z? Z cubed for first term, z to the power of 4 for third term. So, meaning z is not common to the 3 terms. So, only 2 is the GCMF. Now, proceed. Okay, to find the other factors. So, divide each term by the GCMF. So, 28x cubed z cubed minus 14x squared y cubed plus 36y z to the power of 4 divided by h by 2. Okay? So, 2 times 28 divided by 2, that is 14. By the way, class, I divide 2 for the 3 terms. You can also divide 2 by each term. This is the same answer. Okay. So, copy lang. X cubed, z cubed. Then, 14 divided 2, that's 7. So, minus 7 x squared y to the power of cube. 36 divided by 2, that is 18. 18y z to the power of 4. So, that is the final answer. Let's have fifth example. So, you have here 5h plus 40h k cubed. Okay, let's check first if the two terms are perfect cubes. So, since there are two terms, so it could be sum of two cubes. But check if they are perfect cube. So, 5h, that is not a perfect cube. 40h is not also perfect cube. So, it might be there is GCMF, or greatest common monomial factor among the two terms. So, what would be the GCMF? So, the GCMF is 5h. Okay, you factor 5h for the two terms. So, you divide each term. 5h divided by 5h plus 40h k cubed divided by 5h. Okay. Okay, so you have 5h. 5h divided by 5h, that is 1. Plus 40 divided by 5, that is 8. H divided by 8, that's 1 also. 8 times 1, that's 8. And then k cubed. Okay. Previously, we had already discussed the factor of 1 plus 8k cubed. Factor for 1 plus 8k cubed from our example number 4 are the sum of 1 and 2k, and then 1 plus 2k plus 4k squared. Okay. That's all for sum and difference of two cubes. Stay tuned for another lesson on factoring techniques. God bless.